Mole mass and mole volume relationships. To convert between the mass of a substance and the moles, we're going to use the molar mass, which comes from the periodic table. So for example, what is the mass in grams of 3 moles of sodium chloride? Start with 3 moles. If I want to go to the mass, I need the molar mass in grams per mole. For sodium chloride, 1 sodium times 23.0 from the periodic table, and chloride, 1 chloride times 35.5. Add those together, we get a molar mass of 58.5. Multiply, that will give me the mass of 3 moles. 176 grams. Okay, next example. We have 4.52 times 10 to the 24th molecules of a compound, and I want to know the mass. I can't go directly from molecules to grams, but I can go from molecules to moles, because in 1 mole there are 6.02 10 to the 23rd molecules, Avogadro's number. And then once I'm in moles, which is kind of my intermediate units, I can go from moles to grams, because in 1 mole the amount of grams comes from the periodic table. And again, you don't have to show the work for molar mass, but I've got 20 carbon times 12. I'm going to add that to 42 hydrogen times the molar mass of 1, and I get a molar mass for the compound, 282. So anytime you see grams, go back to the periodic table and get the molar mass. When I divide and multiply, I get a mass, 2,117 grams. Next example, I'm starting with grams. I want to go to moles. So I will take 0.37 grams. If I want to go to moles, again, I need the molar mass, but this time I'm going to divide by the molar mass. Boron from the periodic table has a molar mass of 10.8. So in 0.37 grams, I would have 0.0343 moles of boron. Example number 4, I've got 75 grams of calcium chloride. I'm going to start there. I want the number of formula units. I have to go back to my intermediate unit, which is the mole. So I'm going to go from grams back to mole. In 1 mole, the number of grams, again from the periodic table, you've got calcium, you've got chloride. 1 calcium, molar mass is 40.1. 2 chloride, molar mass 35.5. When you add those together, the molar mass of the compound is 111.1. And then go to formula units. In 1 mole, the number of formula units, since this is an ionic compound, is 6.02 times 10 to the 23rd. So mole is the intermediate unit in all of these problems. We got to take what we're given, convert back to moles before we try to go to another unit. Mathematically here, the number of formula units, 4.06, 10 to the 23rd. The mole volume relationship. The mole volume relationship works for gases because equal volumes of gases at the same temperature and pressure contain equal number of particles. The mole-volume relationship will not work for liquids or solids. The volume of gas is normally measured at standard temperature and pressure, which is STP. Standard temperature and pressure is 0 degrees Celsius and 1 atmosphere. At STP, 1 mole of any gas occupies 22.4 liters. 1 mole of any gas occupies 22.4 liters. So that's called the molar volume for the gas. So let's look at an example with the mole-volume relationship. We have 3.2 times 10 to the negative third moles of carbon dioxide. I want to go from moles to volume. So I want to go to liters. Since it's a gas, 1 mole of this gas has a volume of 22.4. So the volume of this many moles is 0.0717 liters. If I want to go from liters to moles, same conversion. I'm going to take 0.2 liters. It's a gas measured at standard temperature and pressure. So that means there are 22.4 liters in a mole of this gas. So 0.00893 moles of hydrogen gas. We can use that molar volume, the 22.4 liters per mole, to solve for density or solve for molar mass, depending on what we're asked for in the problem. Let's go through a couple of problems here. We're given the density in grams per liter at standard temperature and pressure. What's the molar mass? Here's what I like to do on these problems. I want to end up in molar mass, which has units of grams per mole. That's where I want to end up. I know the density. I also know 22.4 liters per mole. Since grams needs to be in the numerator, I'm going to start with the density, 1.964 grams over liter, like that. That will give me grams in the numerator because I need grams in the numerator over here. I'm going to get rid of liters. I need to go to moles. The way to do that is 22.4 liters per mole, because this is a gas measured at STP, so your liters will cancel, and my units, grams per mole. So the molar mass of this compound is 44 grams per mole. If I'm solving for density, again, I like to determine what the units are at the end. Well, density is grams per liter. That's what I want to end up with. Again, I know 22.4 liters per mole, and I know it's krypton, which if you look on the periodic table has a mass of 83.8 grams per mole. So since grams needs to be in the numerator, I'm going to start with 83.8 grams per mole. That will give me grams in the numerator. I need to get rid of moles. The way to get rid of moles is 1 mole, 22.4 liters. Your moles will cancel out. My units left, grams over liter. So divide by 22.4, and you get a density, 3.74 grams per liter. So the mole is at the center of all chemical calculations. It is the intermediate step. If we're going to go from one unit to another, we have to include the mole.